Hi everyone, if you are on chat right now, welcome to the IoT Show Deep Dive. We would love if you ask your questions on chat. We have myself, Mark, cloud advocates who are waiting to answer all of your questions. So we're gonna get started in a moment. Thank you. Hi everyone, welcome to the IoT Show Deep Dive. This is a show where we're going to actually deep dive into different demos, scenarios, end-to-end solutions. So I'm really excited for you guys to join us. The thing that we're going to focus on today is actually Intelligent Edge. You guys have probably heard about Intelligent Edge. For the last couple years, we've been really trying to showcase our different services, but also it's what a lot of our developers are asking for more information about. So today we're going to be focusing on predictive maintenance on Azure IoT Edge. So I have Mark here.
Hi there.
Would you like to give a little bit of information?
Oh, should I give a little information about myself? Would that be better than just saying hey?
Yeah.
Yeah, hi, I'm Mark Midland. I work on the Azure IoT end-to-end team, which sounds like a crazy thing to say all at one time. So basically our job is to take a look from a customer's perspective, outside in. What's it like to use the Azure IoT product sets? What's it like to use Azure for IoT? And how can we make it better? I was telling Pamela beforehand, I like to say that it's on our best day, it's like we're having a hackathon, and on our worst day, it's like we have to stand in a delivery room and tell somebody their baby's ugly.
Yes.
Which isn't that fun.
It isn't. My name's Pamela Cortez. I will be your host. My experience is I spent many years coding with partners and customers. Before that, I was a hardware engineer. And I shouldn't say before that, I'm still designing boards. But I'm here to give tips and tricks from experience with coding with different partners and customers. So I'll insert different, I'll keep interrupting Mark throughout our walkthrough about some helpful resurces for you guys.
That's good, because I'm sure people will be sick of listening to me by 2 minutes into this.
Yes, all of you, all the folks, we're gonna be doing this walkthrough. Are you ready?
I am, so.
Okay, perfect. So today, we actually are going to go through this and treat it as 7 different steps. And the scenario that we're focusing on is predictive maintenance. And I would probably say everyone that I've worked with is all about predictive maintenance or remote monitoring or image processing, anything like that. But I'm really glad that we picked predictive maintenance to focus on today. And this is actually going to be focusing on building a custom model and deploying it on Azure IoT Edge and running it there and sending data back to the cloud. So we're going to do that in 7 different steps. First, we're actually going to just be going through the intro.
Right.
So technically, it's not a step.
So
but
like 6 steps. So
yeah,
it just got easier. It's one step easier than you thought it was.
Exactly. So this intro, we're going to go through this scenario. We'll make it nice and quick for you guys because we really just want to deep dive into that walkthrough demo. The second thing is we're going to talk about how to set up your machines. This normally takes a while, and we have a couple tools to make that easier, but we're going to run through setting up our dev machines and our Azure services. And we're going to do kind of the fast track way of doing it, where we've done some of the heavy lifting beforehand, but we're still going to show you each step of how we created or set up our dev machines.
Yeah, and it's fair to say we've got it all documented too, so you'll be able to reproduce it no matter what.
Exactly. And normally a lot of the time, this process can take, a couple days. It could take, a week, depending on
how much time you have to put into it at any given point.
Yeah,
for sure.
And what type of solution you're building as well. So the next step is for us to actually collect that data. And so we're going to be collecting data that we can then move to the next step about training the data and getting that working with our ML model. The next thing we're going to be doing after we've trained and deployed the ML model is configure an IoT Edge device. So for today, we're not going to use these fun different hardware devices. We're actually going to use IoT Edge on Ubuntu VM, and that's mostly because it's easier to show. In future deep dives, I will definitely be bringing in devices, and we're going to be showcasing how to work with the Jetson NVIDIA line or the NVIDIA Jetson line, the Qualcomm Dev AI kit. We have a couple videos on it already. So I will make sure to link some videos that we have and showcase some upcoming videos that we will have for deep dives. Next, we're going to create and deploy the IoT Edge modules. This, when talking to partners and customers and other developers, this seems to be the most challenging part to wrap your brain around, is working with Azure IoT Edge. So we're going to try to simplify it. We have some great diagrams, and also we'll be going through the solution as well. And the last thing is we're going to send data to our IoT Edge device. All right, I'm excited. Let's go ahead and get started.
So the scenario that we chose for this, we looked at it a lot of different choices how to kind of work through this, and ultimately in the end-to-end team we came up with, we wanted to do predictive maintenance. We wanted to do remaining useful life as opposed to sort of a classifier model based predictive maintenance, and we wanted to use something that looked like the kind of data that you guys would normally run into out there. So we ultimately decided to use some data that's been kicking around the internet for a while from the PHM08 data challenge, which was basically simulated data from a turbofan device, a bunch of turbofan devices. They give you a couple of different sets of data, so you have training and testing sets and kind of different sizes. So if you really want to wait around a long time, there's some bigger training sets, and if you're really lazy, there's some little training sets. And we tried to pick the Goldilocks one, so we took the one in the middle. But there's a lot of data in there, and what we'll do is just take that data and simulate a device, push it through to the network and into the IoT hub, and we'll be off and running. So we can get into that.
Yes, and data is key. And I'll repeat that because there's many times where teams get started and they don't have a data set to work off of. So definitely, before you start working on your solution, understand the data and what you're actually trying to achieve with that data and the data that you need to collect. So do we want to go ahead and?
Yeah, that's true. I think that one of the things that we ran into early was, oh, what if it's video data or sound or whatever, and there's a lot of different considerations that go with it. How big is this data going to be? How much do we have? Do we already have data someplace archived that we can use for this? And so I think there's a lot to think about here, but we tried to make it a little bit easier for today.
Exactly. All right, so we're going to go ahead and share your screen.
Okay. Did you want to go through the overview slide? Or are we good here? We took care of that?
Let's go ahead and go over through that overview slide. I think that's a great idea.
Okay. So it's basically those same. I guess here we've got it down to 5 steps. So in 3 slides, we've gone from 7 to 5. I feel like we're doing our best to make it simpler.
Yes.
So basically, if you look at what you've got here, is just like we said, we're going to collect the data. We're going to prepare and experiment. That's going to be mainly using Jupyter notebooks. Now, the data scientists out there among you will say, but there's lots of other ways to do this, and that's absolutely true, but I'm not a data scientist, and I don't even play one on TV, so I just do what I can do. And then we're going to deploy a trained model to the IoT Edge. That'll be sort of the modules bit, and we'll go through that in some detail. And then we'll use that model, run the device and model, and then the last step we'll actually leave for future versions of this, which is how do I take the data then that's been cycled back and use it for later modeling, and we'll just we'll leave you at the point where you're ready to do that, but we won't actually do it. It's a lot of gymnastics in there that really go to how do you run your organization and less to how you do IoT Edge.
Exactly. All right, let's go ahead and share your screen.
Okay.
And I like that you pointed out that there is many different ways of doing this, and this really depends. Not everyone's going to use Jupyter Notebook. Not everyone's going to want to make their models in C# or Python. Maybe you want to use, C or C++. So there's, a lot of different ways that you could be setting this up. So really the key of this walkthrough is to showcase these different steps and different things that you have to think about when doing this.
Right. Yeah,
solution on the edge.
For sure, and we'll try to, I think as we go through this, we'll try to give you the tools that you need to get through it yourself, not so much to do exactly what we did, which may or may not be interesting for you. So just as I'm starting out over here, we're looking at kind of how do we set up our VM. So we did, when we went through this the first couple of times, we realized like there's a lot that goes on to your VM if you have a job like I do where you're kind of changing technologies a lot and switching things around. It gets a little bit messy to have all that stuff on your local VM, and so we decided it would be easier on everybody to put a dev VM into Azure. And so if you look in, I maybe should have started with the on GitHub. We have this sample published. And so what I've done is just clone that to my local box, and we're just looking at it here in PowerShell. And you can see in the underneath the dev VM folder, that's the word. Yeah. We have a bunch of scripts here. And the key one that you want to know about here is create Azure Dev VM. So I'm going to go ahead and get that one set up, and so we need a subscription ID, and I've cleverly made a couple of variables behind the scenes so that I don't have to show my very secret subscription ID that nobody can know about. Resource group, and I'll just say while we're on the topic here, and you'll see in a second when I switch over to the Azure portal, use the same resource group for everything as you go through this, because then when you get to the end and you're ready to clean up, you can just delete that resource group. You don't have to go find all of the things that you might have created in different spots. It'll just make your life a lot easier.
Exactly.
There's a person talking from experience of not having done it before.
So Mark is showing you how to create a VM, and I personally, when anytime working with building models or anything like that, I like to use a data science virtual machine.
Yeah, it's a great resource. We've used it quite a bit, but we just didn't happen to use it in this particular walkthrough. But we have used it a lot, and it's definitely a great resource. And I think it comes in a bunch of different flavors too, right? I can get an Ubuntu one, or I can get a Windows one. I think there's a couple different, at least a couple distros. Yeah. So you can see here, I've gone ahead while Pamela was talking and filled in the command, and then I've given it a password. And so you can see, because I have already run this script, it's going to say it's going to skip over it. And so I'll just bail out at this point, and we can go look at what the VM looks like instead of spending time on this. So so we're going to pop over here to the VM. That may have been a little bit quick, so you may not have noticed because I didn't actually log in. I was already logged in. But so now I'm looking at a remote desktop view of my virtual machine that we've created. And I'll go ahead and open PowerShell. I probably should make that a little bit bigger so that people can actually see it.
And also working with different teams and different organizations, one thing I notice is lots of times when going to a company, the data science team is off in their corner, and what you would consider the traditional IoT developers are off in their own little corner as well, and then the IT department is off in their own little corner. And one thing that's important when building these solutions that involve intelligent edge is that you need to bring these folks together, but doesn't mean the tooling has to be the same though.
Right.
Sometimes the data scientists will use a totally different VM or different tooling than the firmware engineers or other IoT developers, but as long as you guys understand how big the model needs to be, what the goals are, what devices you're using, and have that base requirement, I think that's important. But I do recommend that both teams need to get together to talk about how they're building this solution. It's not as easy as just handing it off to the next team after you've created a model, because you could be the best data scientist out there and build this beautiful model that doesn't end up, it might be too big to run on the edge device. Right. So definitely have that open communication.
Yeah, I think this is really a case where it's obvious that software is a team sport, and you've got to work
more
together.
So than other solutions. Yeah.
I think from the purpose of this walkthrough, we sort of have taken the viewpoint of the solution developer, which is to say, somebody who's not so well versed in the hardware side, or somebody who's not so well versed in the machine learning side, with the hope that you can kind of see how the whole system fits together.
Yeah,
but
exactly.
That's even as we were going through this, we were going out and finding people who knew something about machine learning to try to get some help and hopefully get a reasonable models put together. So I just have logged into the machine here, and you'll notice that we've already cloned the repo for you onto this machine, so you don't need to redo that because that's boring. And so I'm sitting in there, and here's the list, and you'll see the PDFs that are in there. Those are kind of our current walkthrough. They're all stamped draft, but they're all pretty well tested at this point. So if you're confident that following through those, you'll be able to get to it. So I'm just going to go in and maybe just first thing to do would be just to see if I get this command right off the top of my head. Yeah. So the first thing is we've installed some software for you. We happen to use it, install it using Chocolatey, because I think I might have mentioned earlier, but for sure I'll mention it now. I'm lazy. And so doing anything that actually causes me work seems not so much fun, whereas Chocolatey is pretty much saves a bunch of time. But you can see the big things that I would call your attention to. We've put Azure PowerShell on there, Docker Desktop. That's pretty important. And by the way, when you log into the machine the first time, you'll need to go ahead and start Docker Desktop. If you forget, you'll remember when you try to do your first Docker build, and then it says that Docker doesn't exist. And then we've installed Python as well, and of course, Git and so forth to be able to clone. The second thing I want you to take a look at when we're on this machine is there's a script here called enable code extensions.ps1. And again, I've already run that on this particular machine, but do this. So if we open that up in code, VS Code, you can kind of see what we're doing here is we're going through and we're just installing a bunch of extensions that you're going to need when you get going, and you can see the same list here showing installed extensions. You'll see that those are suspiciously familiar to each other. So that's kind of getting the machine set up. That's all you really have to do to get started.
One thing I do want to point out is here. Let me show up my laptop real quick. As part of the script that you're running, does install the Azure IoT Tools extension. If you haven't worked with it yet, I'm a huge fan because it makes it so easy to create IoT Hub, see your devices, and even your IoT Edge devices. So this tool is actually an extension pack. It installs 3 different extensions within VS Code. One is IoT Hub Toolkit, one is IoT Edge, and one is the device workbench. The device workbench is really for folks who are coding with the MX chip, coding with Raspberry Pis or anything like that. So technically, you don't really need that extension for this
particular walkthrough.
For this particular walkthrough. But I also want to make a mention that VS Code, I love VS Code. I mean, like, I'm going to keep inserting this in every single deep dive, that, you know, it has the tools and extension and a lot of support for Azure IoT. However, Visual Studio, we just released the support within Visual Studio for IoT Edge. And I think that's important to mention out, because every time I'm coding with folks who are used to Visual Studio, they're always like, I don't want to install VS Code.
Right.
I already have this super powerful IDE. Please provide that extra support for Visual Studio as well. And so that is something that we're definitely doing. And so I recommend folks to check out, if you have Visual Studio, check out the support for IoT Edge.
Yeah, obviously it's a great tool. I think the other thing that's great about the IoT tools is it was about halfway through putting together this walkthrough that the IoT tools shipped as an extension pack. So not having to keep track of which things needed to be updated anymore was fantastic.
Exactly.
So while your machine is actually installing, you know, although we did it in a very quick way, it'll take a few minutes if you install the machine in Azure, obviously. Copying bits around, physics and whatnot, I don't know. You can take that time to kind of flip over to, you can see now I'm in the IoT Hub folder within the repo, and we can actually do the new hub and storage PowerShell. And what that's going to do, and I have it set up here to run again. What it's going to do though is it's going to go set up your hub. It's going to get that configured. It's going to configure your routes. It's going to put storage accounts in there. You can do all of this stuff by hand via the portal, and you know that's fine if that's how you like to spend your days.
If you're a portal girl, it's good. But if you're like me, I like to do things through VS Code and through command line. So
it makes it a lot easier.
I'm a fangirl of that.
Yeah, and so. I can run this. You'll see it's going to look exactly the same, and I've already done this as well, so we won't run it again because it's just a waste of time. But we will go look at what it created, and also you can look in here and you'll see that there's a hub and storage.json, and if you look into that, that's an ARM template. ARM templates are thorough. I'd say thorough.
They're super useful.
But they're useful, but they take a little bit of getting used to if you haven't done a lot with them. So that's maybe a good way to kind of take a look at how we've set everything up. So now I'll walk over to the portal here. Now you'll notice I'm looking at a resource group, and this is the resource group where I've put everything, because I might have mentioned earlier, but I'll say it again. Put everything in the same resource group. Then all you have to do is delete that resource group when you're done. You don't have to go chasing different resources all over Azure, which gets to be very painful. So you can see here one of the first things we have is the IoT Hub. So I'll just pop that open. So this is what the script has created. It's created an IoT Hub for us, and down under messaging, you'll see message routing, and the script has added in here this turbofan device data to storage route, and the RUL message route is giving away the ending a little bit.
It's okay. It's fine.
Is a route
alert.
that we'll add closer to the end. I've put it in here just so that it was ready to go when we got there. Yeah. So that's what you get. And if we kind of drill into this a little bit, I think it's worth taking a look. So it's a routing. You've got a routing query. This will say true when you come in here. That's the simplest way. If you want everything to go, just say true. It'll be there by default. And then we've got an endpoint, and you can take a look at the endpoints in some detail over here on custom endpoints. In this case, it's a storage endpoint, and so we've got the routing set up. We've changed the order of this of the blob file name format. By default, it puts the partition first, which is less helpful than you might think.
A little confusing.
And so that's what you're going to see, and then this points over to a storage account, and so everything's there. We don't have to spend any more time worrying about it, and we're just ready to go on to the next step.
I think since you've mentioned storage, one thing is you can have storage on the edge as well. The storage is in the cloud, but there is support for blob storage. That's a container on the edge device.
Yeah, and that's great if particularly if you're looking to sort of use the same semantics between the edge
Exactly.
and the cloud. And also, I think I just saw maybe on the IoT show actually that they've added what they call tiering, which is basically they can, when you set up your IoT edge storage, you connect it to a storage in the cloud, and it automatically uploads. And,
Yes.
and in this
Yes.
case, because that wasn't really available at that time, we had to write our own upload code. And so, yeah, it's really nice, a nice addition there.
So now we're ready to actually create that training data for our ML model. So we're going to go ahead and jump into that. For the purposes here, we're just going to use a simulator. So let's go ahead and jump into that.
Yeah, so you can see by the blue bar at the top that I'm back over onto the dev VM, and for the most part I'll be on the dev VM the rest of the way out. So if I forget to mention it, that's what I'm doing. So in our clone directory here, we have a folder called device harness. And so what I've done simply is just open that folder in code. And now I think the first thing that you'll be looking at when you get here, a couple of things. One is likely when you come in here and open a C# project for the first time, you're going to get a bunch of, hey, do you want us to enable this extension, or do you want us to enable that extension? And you should say yes to that. And also, would you like to restore the things that are needed to build? And also, you want to say yes to that.
Yeah,
so,
just keep saying yes.
So yeah, so you'll want to watch. One little trick is if the pop-up comes up and goes away and you missed it, which happens to me occasionally, the notifications will show up with a little bell icon down here, so you can get back to them and say, oh yeah, I actually did want to install all the Edge tools and the C# tools and make sure my stuff will actually work.
And if you don't have that blue bar at the bottom of VS Code, the status bar, you can actually go to File Preferences and type in your status bar into search, and you'll be able to toggle that on and off.
Huh, I did not know that.
Yeah, I'm full of tidbits.
Helpful little tip.
Any way to go faster on things.
Yes. So there's lots of different ways that we could sort of configure our hub and get there. I actually really like using the hub panel inside of VS Code. I find it super handy, really nice, really easy to do. So I've cheated again here and already done this, but let me just say what we'd want to do is select an IoT hub, and then out of these 10 billion choices, I'll select that one subscription, and then from that subscription I can select the hub that was just created for me, and a little bit of status will go by here, and then you'll see the hub open up. When you get the hub open up, what you're going to see is a blank, because you won't have yet added anything. Your devices won't have yet run. Exactly. And so that kind of leads me to what's this project that we have open here. So the Turbofan device project does a couple of things. One, it simulates a bunch of devices so that we can run as if we've run 100 days of data or whatever over 5 minutes. And the second thing that it does is it will simulate a single device talking through an edge gateway, and so we'll talk about that obviously clear at the end. But it's the same project both ways, so it's the same bit of code, and all we do, just super simple, is just read the data. It comes in a text file from the NASA data that we're using. I don't have it handy here, but and just read that text file in, parse the text file, turn it into devices, and off we go. So how do we run this thing? Super simple. We just go .NET run, and if the demo gods are with us, we'll get to this, and now it's going to ask me for what's my IoT Hub connection string.
And I'm gonna do some.
Oh, you don't need to. This is okay, I think.
Okay.
We'll be deleting the hub in any minute now. So, so I just copied. I don't know if you guys caught that. So, just click on the ellipsis here, and then copy. No, I can't see it. Copy IoT Hub connection string, and I'm just gonna right-click to paste it in there, and hit enter.
Yeah,
and then you'll see. Oh, sorry. Go
Oh,
ahead.
I was just gonna say that extension is so nice to use because you have all of those. I mean, you could be doing this without the extension and finding all the information through the portal, but yeah.
Certainly you can do it lots of different ways. You could use the Azure client or something like that. The CLI does it. This is just super handy. The other thing I love about this is you notice that I refreshed once we got started here, and all these guys turned green. So in the case of starting fresh, what you'll first see is you'll see a bunch of devices get created, populated. So you can take a look at the code in there if you want to know how to make that work. And then you'll see them all start turning green because we're sending data. And so this thing knows that we're sending data. And as a matter of fact, another kind of cool trick you can pull here is you can start monitoring device to cloud message. I always have to think about that one really hard.
And then cloud to device.
Cloud to device, device to cloud, and then you'll see the messages start to roll through here and get picked up, and you can kind of take a look at what's actually happening. So yeah, super nice. Lots of cool things. I will tell you, and there's always this little hiccup that we run into is sometimes if you have another subscriber hooked to your IoT Hub, you won't see those messages coming in. So particularly happens a lot when you have Azure functions. If somebody you're working on a project and somebody hooks up an Azure function to your IoT Hub, and all of a sudden you stop seeing messages go by in your terminal window, that's why. It's because they've been sucked away and they're no longer going to the default endpoint. So anyway, so that's kind of getting data sent. And I guess the other place to go and take a look at this real quick is if we were to take a look through the storage account that we have created for this purpose. Go to Storage Explorer, blob containers, and then device data, and you'll see, so 2018, April, today is the 8th, I believe.
And it's great that it shows the year, the month, the date, the time, so really you can actually get off the data in a nice structured way, which I'm a huge fan of.
Yeah, so it makes it much easier, and then you can see here's the data flowing into the system, and that's the data. So we're going to use this exact storage account in the sort of next step. We'll be pulling the data from there down into our notebooks and carrying on. So that's that.
All right, let's go to the next step. All right, so there's we're going to be going over 3 different paths that you can really take with the AI model when you're deploying on the edge, and then we'll continue with our walkthrough of the demo that we're showcasing using Azure Machine Learning. We won't be using Cog services today. We have a lot of great videos on that, but today we just built a model. Let's go for it. All right, so there's 3 paths on to get an AI model. I've seen common across many different companies and how they think about ways to attain a model. So first, use an existing model. This is really great for, let's say, teams that maybe don't have a huge tons of like ML experts on their team, or they don't want to reinvent the wheel. Maybe we already have a Cog services that makes sense, like facial recognition. Maybe that they want to go ahead and use that. I mean, Microsoft Research, we've been doing a lot in this area. We have amazing folks who work in Microsoft Research and across the different teams on building these Cog services.
Yeah, and a lot of times it's even like just a little bit of a tweak, and you can get what you need. too, right? Like,
Exactly.
So it's those are they're
Exactly.
super nice. Yeah.
Yeah, I'm a big fan of those. Some things to consider is that we don't have all of the cog services that you can already use in the cloud that's containerized on the edge yet, which means that we're planning on getting these services containerized as a Docker container to put on the edge. But the ones we have now, we're kind of rolling out new cog services. So we have text analytics. That one's already in public preview. We have face detection, which is a huge one that a lot of folks want to use, especially in retail, that they want to deploy on the edge. That's containerized. We also have an edge marketplace too, which I'll pop up in just a moment. And so this is great of using this existing solution that could be reused. Maybe you want to use face detection on your retail solution, and then maybe you want to use that same thing for something different, like a different type of scenario. You can use that same model, train it a couple different ways, and deploy on the edge. The next path is a customized model. So it's a model that you can actually take where you can make it your own, insert your own data, and do some changes to it. And so this is really nice, so you don't have to build from scratch.
Right.
Again, it's Mark is like,
yes.
It's you still need some knowledge when of building models, but you don't need as intense experts on your team to be able to kind of figure this out. Which, again, I've met a lot of teams where they have amazing rock star data scientists, ML, experts on their team, but there's only so much bandwidth you have.
Yeah.
So if there's a model already you can customize, like our custom vision, go ahead and use that model.
Yeah.
One thing I would like to just mention real quick is I have a lot of folks who see the cog services that they could deploy on the edge, get really excited about it, and then find out you do have to phone home for billing purposes. So if you have like extended offline capabilities that you need to do, like would say you deploy a model, you use one of the cog services, maybe facial detection, and you put it on an oil rig, and that won't have connection to internet for a really, really long time. You have to consider the limitations of how you have to bill back. And that's changing. I know the COG services team is looking into that and making those changes, because there are people who want to use those models and have them on edge for a long time. And I also get the question of what happens if if I do put it on an oil rig, this like face detection, it's on my edge device, I deploy it on the oil rig doesn't have any internet, how long will that model last? Will it last for 2 months? And what will end up happening is when it tries to phone home, meaning that phoning to the cloud for billing, it stops. The model stops, and so that's definitely the
kind of unfortunate, but I'm sure we're working on it.
Yeah, we're definitely working on it. And the reason why I bring that up is you need to understand which path makes sense for your solution. And definitely work with us, our COG services team. If you do have an extended offline story, definitely reach out to folks here at Microsoft to help out with that. And the last one is build your own. You guys are rock stars. You're ready to go ahead and build your own model, or maybe you already have your own model that you can make it into a container and get it deployed on an edge device. If you already have that, we have that capability where you don't have to, you're not tied into our models only. You could bring in your own models. And so you can use Azure Machine Learning. You can use your own custom code. So we have a lot of capability there.
Yeah.
All right, so now let's go ahead and jump into building that model.
Yeah. So so I'm starting here with our at notebooks.azure.com. It's certainly possible to do this on a Jupyter Notebook server that you run yourself, or on your local machine, or whatever. We use Azure Notebooks just because it's convenient for hooking to the Azure itself. Also, a lot of the things that I need installed to make the notebook work are already there, so I don't have to worry about getting Azure Machine Learning installed or anything like that. So when you come in here, you're going to see that you need to create a project. I've got this Turbofan notebook, and then you'll go to the GitHub repo and just upload the files from there. As again, pretty clear walkthrough. Hopefully, a pretty clear walkthrough in the in the documentation that'll help you get through there, and then you'll end up with these kind of 2 notebooks, and they're conveniently labeled 1 and 2, and that's because that's the order you should do them in.
Try to make it super simple for you guys, and there's a lot of documentation too on how to work with the Azure notebooks.
Yeah,
that's working with Jupyter.
Yeah, I think the only speed bump that I'm aware of really is you kind of have to create a account in Azure Notebooks, and it's a little separate from your Azure account, which can be a little confusing, but just roll with it, pretend like it's a different service, and carry on, and then things will work out really well. So here we are in the first notebook, and you'll kind of see we start at the top, and we just do a little bit of setup. We just kind of getting the notebook configured. I get this error every time. It's fine. Just carry on. Just don't let it bother you. And then we do some copying of data around. That just kind of organizes stuff. That way you don't have to try to organize it when you put it into the notebook. The next step, and this is a pretty important one, is to set all of the global properties. Oh, and I should say, I'm sort of scrolling through this, but as you go, what you're going to want to do is hit Control Enter or Shift Enter to help you to execute each of the steps, and then that'll sort of let you go from one to the next. And I can do that here because it's super fast, but and then you'll notice that you get a number here, in this case 1, for the execution that you've done. If you see an asterisk, that means the kernel is still busy doing what you asked it to do, so maybe don't go on.
Yeah, exactly. And at least when it's running through the different cells, you could choose to run through the cells individually, or you could just run through all of them, which is really nice, especially for debugging. But if you run through all of them, if there's an error, it will stop.
Right.
So you are able to go ahead, see what that error is, fix it. Maybe it's just not even an error. Maybe it's just log in to Azure right now, and here's your code or whatever. But at least you will see that. So if it doesn't look like
if you're in a hurry and you want to just run them all, you could definitely do that.
Go ahead, but it will stop if there's error.
Right, for sure. That's great. I forgot to mention that. So here we kind of talk about the Azure Machine Learning workspace. So to summarize, the Azure Machine Learning workspace is a group of resources that really just kind of help us get all this stuff done. So it's some storage, it's a key vault, it's Azure Container Registry that we're going to use here in a minute. There's a bunch of resources. By creating one of these, we don't have to do all of that other stuff. Yeah. It just makes it a lot easier to go through, and we can take a look at that in a few minutes here. So that's all this is doing, and then the next guy is going to just spit out, here is your workspace information. Now we start to get a little bit more into the interesting bit here. So here, what we're doing is we're registering a data store. So this is the data storage account that we showed earlier, where the data is going to. So we're just saying, hey, hook this in and use it so that I can pull it from my machine learning account. And then the very cleverly named download data. We're downloading data locally. Now, I mean, this is a crazy thing to do if you have 18 billion, terabytes of data, which probably
you got
or something. But anyway, so you don't want to do this. Yeah. What you would want to do in that case is sample. We have a little bit of data, so we just brought it all because I may have mentioned earlier I'm sort of lazy. We're gonna create a script here that's just gonna help us format the data a little bit, and then we're going to actually load the data from the download files in Avro and pull them up into some pandas data sets that make them a lot easier to deal with and work with as we go. And those machine learning people out there are going, duh. And those of you solution developers like me, what's a pandas?
What is pandas? Yeah.
So and then you can see.
Did you want to give a little bit more information?
What
there?
about pandas is? It's a way to represent. It's a library for representing tabular data and working with tabular data. It lets you do some pretty cool things if you need to run a bunch of the same sort of operation across all of the fields or all the rows in a table. It really makes it a lot easier to do that. So it's super handy and also makes it so you can print nice little charts out like this. And then here we're going to calculate the remaining useful life. So the remaining, and you see we did both. In this case, we did class labels and we did actual remaining useful life. In the NASA data set, conveniently, for what they call training sets, the last row that you see of that data means that the engine died. That's when it broke. And so you can basically say, based on the cycle data, subtract the max cycle data minus whatever I'm on, and that gives me the current remaining useful life in cycles. And so that's all we're doing here is kind of calculating that out.
And then soon, when you can figure that out before the engine dies, you can actually set a rule or actually have insights from that to drive back into business impact.
Exactly.
So maybe alert the field worker that the engine needs to be worked on or switched out or
exactly. And so that's and so then here we've got our training data, and you can see that in addition to all of the sensor data that we uploaded. I guess we didn't talk about that too much, but the shape of this data is basically 21 sensors, 3 operational settings, an engine name, and execution until it dies. So that's kind of what we started with, and so you can see here we've got the max cycle for this particular thing and how many remaining useful cycles we have left, and then the RUL class, which we kind of made up, is sort of like 25 days away or 25 cycles away from failing. So that's kind of how we use that. We don't actually build the model that way. We didn't find that it added a lot, so we just went ahead with the remaining useful life classifier. But in case that's something you want to do in your spare time, it's there for you. Yeah. So you have it. And then the next thing we kind of do is just try to plot some of the data. And take a look at what it looks like and how it changes over time. So you can see as sensor 2, you can see there's this kind of trend over time, and as the engine is wearing out, sensor 2 is going higher. By the way, it may say somewhere deep in the documentation, but nobody really says what the sensors are, what they measure. Just kind of take their word for it that it's important. And you see some of them are pretty useless for doing classification because they don't move much. Some of them do crazy things like this, and who knows what you're going to do. So anyway, it's a way to kind of take a look at the shape of the data. For me, again, coming from not a lot of machine learning, it really helped me take a look at I can kind of visualize how the data looks and what we're doing with it and what we're trying to do. So that's what it's meant to do. We do the same thing with operational settings.
It's good to see all the sensor data, but as you mentioned before, what data is actually important? What do you need to capture? And I think that's just super important to understand before you start building all. I mean, you're going to look through these models and you'll pick that out, but it's just really important to spend time with the data. And data scientists out there are just going to be like, okay, she's preaching to the choir. But I've seen way too many times folks just say, here's some random data, here's a temperature sensor, and then it doesn't make any sense, or it's not the right type of data that's needed for your solution.
That's right. And so it's really helpful to take a look and kind of get a sense of what the shape of the data is and what should be included and what should not as well. The next thing we do here is just within that Azure machine learning workspace, we create some compute. Like we need a place to run our model, to train our model with, so that's what we're doing here. We're creating some compute, and you'll see, we create it with 0 running nodes, and then add up to 3 nodes when we actually run. So you're not getting charged while it's just sitting there, because it's not doing anything. Why would you want to pay money for that?
Exactly.
And then we finally get around to the good stuff here. We set up a data reference to that data that we just were working with in the data store. So when the Azure compute machine comes up, it'll actually mount that data and start running with it. We add some run settings. We created the data script. All of this is covered in some pretty good detail. And then we get down here and we actually set up the experiment and run it. Yeah. And this is kind of the money part. So you see, we've gone in and we've run this model, we've run this experiment. Azure Machine Learning, thankfully, has gone through a bunch of different algorithms and tried a bunch of different things, and we've limited it to 10 in a minute just because we didn't want you to wait forever. But we go through and we come back with the best model, and then the next step is to register that model within the machine learning. And then for the rest of this notebook, what we're basically doing is taking some of the test data that came along and just comparing how well we do. This is probably the best thing here. Like here's how we did for the actual data, for our training data, actual versus remaining useful life, and you can see it's not the greatest model in the whole history of the world, but it'll do. And here's kind of test data, and the shape is more or less the same, and we do sort of okay. And then we run some more tests down here that certainly the data scientists in the crowd will recognize and most likely say, oh, but you should have fixed that because that S-shaped curve clearly means that this is not normal, which I kind of understand most of those words, but we haven't put any effort into making this a great machine learning model. We just needed a model so that we could use it for the next step here.
Exactly.
All right, that was a blistering trip through that guy. So then we'll take a look at the second model, and the second one we're doing really the second half here, which is we're going to take the model that we just built. We're going to build a scoring script so we know what data we're going to get through from our Azure our Edge runtime, and we're going to build a scoring script. And then we're going to deploy that as an image, a Docker image. We'll set that up as a Azure microservice and run some data through it just to make sure we get what we expected. And then we'll save that image off and we'll use it, actually deploy it to the edge. So we're getting close. We're getting close to the actual edge part of this.
We are getting close. And we'll bring up a diagram too to kind of showcase what actually happened when you build this model. How are you deploying it on the edge device? Because I know we went through that Azure Notebook pretty fast.
Yeah. So
but building your own model is it takes a lot of steps. Yeah. There's definitely a lot of steps, especially when it comes to training.
Yeah. Yeah. So if you take a look through this guy, like Pamela just said, you've got a bunch of steps here. We create the scoring script. We create the YAML file, and then here you actually see us create a container image. That'll take a little bit, and then we deploy that as a web service on ACI, and then we
Azure Container.
Oh, sorry, instance. Azure Container Instance. You could use Kubernetes or AKS or whatever you wanted to as well.
Azure Container Services.
Yeah, I never can remember. I never remember the full
every acronym. I'm going to go ahead and
just fix for me. And then you can see, okay, we've done what we've predicted to make sure things look right, and then we basically produce the same graph again just to say, oh look, it does look the same as it did previously. And so maybe just one last little place to take a look here is if we come to the machine learning service workspace, I just kind of want to point out that there's a bunch of stuff going on in here. So we talked, there's a storage account and a container registry. There's a key vault, which we're going to use a little bit later. Application insights if you need it. And if you go down to experiments, you'll be able to see the experiment we we just were running, and the results of that experiment, we just took a look at them really. And over here under images, you'll see the image that we created. So this is the image in the Azure Container Registry that we're actually going to be deploying in a few minutes. So, you know, just when you need a sanity check, where is everything? You can pop over to look at your machine learning service workspace, and everything will be there.
Yeah, and we'll go through in more depth of what the word image actually means.
Right.
Because I think if you haven't worked with IoT Edge before,
or Docker,
Docker, we'll get into that in just a moment after we've created our Edge device.
Yeah. All right, so should we?
Yes, let's go ahead and let's
look at the Edge device itself. Yeah. So the Edge device. Once again, so Edge. I think we mentioned this earlier. Our Edge device in this case, we're just using an Ubuntu virtual machine in Azure. So much like we did earlier, if you come into our repo, you'll find Edge VM is one of our Edge devices, and you'll see in here we've got something to create the Edge VM with, and then install some packages on there, and what you'll end up with is an Edge VM, much like this that you'll in Ubuntu VM.
One thing.
Go ahead.
Oh, I was just going to say, when you're creating that IoT Edge on Ubuntu VM, by default, it doesn't enable port 22. So if you want to, SSH, which you will want to, make sure when you're creating it to enable that port, because you'll get an error and it'll be like, you can't log in.
Yeah. So I think we turn on a port 22 in our script.
Yep.
I think we also turn on AMQP and MQTT, and that will be a future source of problems for you if those aren't turned on, because you'll be trying to talk over those protocols and they won't be enabled. So take a look in our NSG our network security group for this machine. You'll be able to see what we've turned on and not turned on, or take a look at the script. I think that the trickiest bit of our whole sort of setting up the Edge device, or Edge VM, is really getting certificates. And so if you kind of go out and take a look at our documentation on the topic, it says something like clone OpenSSL from GitHub, compile that, and then there's like 200 more steps. And so we tried to make that a bit easier. So you'll see that there's a create certificates folder inside of the repo.
Yeah, that was useful.
And what you'll see is there's just a Docker file in there. You'll just want to right click on. So I've opened it in Visual Studio Code, obviously. You'll want to do a build image on the Docker file. That's fine. That was really fast, and the reason it was really fast is because I already built it yesterday. However, you should expect this will take a little bit, right? So you're gonna pull down the image, and then. Do
you want to go into why they're asking you to create a certificate?
Yeah, so we should. Yeah. Maybe we should take a look at that when we look at the walkthrough, because I think it'll be easier to see why that's happening. But and then you just run this Docker file with a command. You pass the folder where you want the certificates to end up, and hit go. And again, the instructions are in there, and I can't think of them off the top of my head, obviously, but. You'll end up in this Edge certificates here. You'll end up with the certificates that you need, and then the second step here is we have upload key vault certificates.ps1, and what we're going to do there is you'll just run this script. Give it the key vault name, which I conveniently just showed you was in the machine learning services workspace. Grab that same key vault name from the portal, and that'll upload all of your certificates there. And then, as a final step, I did mention that this was the most complicated part of setting this up, right? As the final step, you'll need to go and set. In this case, you can see this is my certificate, or my key vault name is this turbofan key vault W key whatever. Yours will be very similar.
Yeah.
And then you can see what we're doing here is we're just doing these AZ commands. So AZ login, AZ account set to the subscription you're using. These AZ key vault download commands, which you'll find in the walkthrough, will get you all set up. And then the last thing is to run this config edge .sh and pass it the IoT hub connection string, which we showed you how to get earlier from VS Code.
Yeah. So you're really just creating that certificate and then uploading it.
That's right. Then and then the final step, I promise, is we're going to go to etc IoT config.yaml. So we're gonna use nano and just edit the config.yaml file. And so luckily for you guys, you don't have to watch me type because I did this before, but the device connection string will already be set because you've picked it up from the previous previously. Then your certificates are going to be set up here, so you'll again you'll want to copy that verbatim and make sure you get those right. If you don't get these right, one of the successes we're still really working on and getting better for Edge right now is if you make a mistake in your config file, it can be very difficult to sort of diagnose what it is. So I recommend kind of make a change, check and make sure everything's working, kind of make a change, check and make sure everything's working. I know it's a little bit tedious, but it probably save you some time in the long run.
I feel like from what I've seen, it's a common issue that people run into, not realizing it.
Right. I think
it's harder to diagnose.
Yeah. And then the other thing we need to do is we need to update the host name. So since we're going to be connecting to this over the internet, we need a fully qualified domain name. So we've put that in there. There's a whole section here that talks about how the host name is going to be lowercase when it gets created. Pay attention to that and use the lowercase host name, or you will have trouble with your TLS connection when you go to connect a device. And then the last thing you need to do, and
the good thing is, there's always mention. There's always a comment that says, make sure everything's lowercase here, and
Yeah, but if you're running through it really fast, kind of like we are right now, you may miss some of those comments.
Exactly.
So take the time. And the last thing here is for both connect and listen, you need to change the management and workload URI. This is really just a side effect of the fact that we're using AML created image.
Azure Machine Learning,
and it's Azure Machine Learning, and that's a fix that's already on the way. It just hasn't quite made it out yet, and you won't have to do that anymore by the time they get into public preview. So that's it. That's all you need to do. Once you do that, you'll hit Control X, and then if you've made changes, it'll ask you to confirm. You say yes, you want to confirm. Save it, and you're done. And then you'll run just two commands really. You'll run this command to restart Edge. There's no real reason to run it right now, but run this command to restart Edge, and then the next command you'll run just to make sure everything's okay. And then hopefully it is, but if it's not, then there's some more commands down below that can help you kind of diagnose what went wrong.
I'll tell you. So far what we've done is first create just a dev machine. Then we went ahead, created or just had data that we gathered from online. But you can simulate your own data. You could bring in data you already have. And then the next step, training that data, making sure it's appropriate, and creating a model and an image that we can then use that we will soon bring into an IoT Edge device. And then the last step that we just did was actually make an Edge device. But we're using a VM for the Edge device. I think it's really important to keep in mind that even though this IoT Edge on Ubuntu VM is amazing, I love to use it for workshops or coding with developers, fellow developers. It's a VM,
Yeah.
so it's pretty large. And so one thing I did want to go over real quick is the fact that there's so many different edge devices. And I think actually the #1 question I get all the time is, hey, can I run this on a Raspberry Pi, this huge model, and then store tons of images on it as well? And so one of the things, sometimes it's kind of hard to answer that question, which edge device to start off with, without understanding the solution.
Yeah.
And so when I think about edge devices, I think about it in like kind of a light edge and then a heavy edge. And it also depends on, are you doing image processing? You know, if you're doing predictive maintenance, how much sensor data are you gathering? So there's a lot of things to think about. Let me go ahead and show some devices on the table right here. So this one is, you know, the AI dev kit is a Qualcomm camera. It's great for just prototyping for security, retail solutions, a lot of different scenarios. What I like about this one is that it actually has, you know, documentation for it. It's supported by Microsoft and Qualcomm. So if you get started, you can easily work with Azure machine learning, Cog services, and just get rolling with this one. And so you can get that a couple different places. And of course, you have your Raspberry Pi, which some people do proofs of concepts. Yeah. Almost said POC. I'm trying really hard to be better at acronyms. However,
TLAs are my thing today, I guess.
No, I'm having a hard time. Yeah. And so, I mean, honestly, I don't really do proof of concepts when doing intelligent edge scenarios on a Raspberry Pi, because you get really limited really fast. Because a lot of the scenarios I'll work with is like image processing. So you have to think like frames per second, how much data you're going to need. And so going back to that slide, I have a couple devices on there. I'm not getting like any type of money. I'm not a brand ambassador, but for NVIDIA,
you're just a crazy hardware girl. That's all.
Exactly. I have worked with the NVIDIA Jetson line for a while now, with the PX2s to the soon I'm getting the Nano to the TX ones. So there's a lot of great devices for different needs with the Jetson line. Intel has a great line as well. I feel like I went to marketer right now, but biggest thing to keep in mind is that you have to know your requirements, and then also think about what are your requirements down the road. There's a lot of people who will build on your solutions and then realize, I just deployed maybe this Dell 3000 gateway device in the middle of nowhere, and I just realized, for this first solution, for the first year, it works great, but I want to do some more intense processing. I want to do, use this for more scenarios, and maybe they should have started off with a Dell 5000 instead. So there's different things you have to think about. I won't deep dive too much here because I'm going to have future videos about working with different devices, and including the DataBox Edge, some of the stuff coming from NVIDIA. But one thing I did want to mention is, with the devices, with using IoT Edge, the device needs to run Docker. So at minimum, this device needs to be able to deploy a container on there. And so one of the things we have is the catalog, device catalog, which has IoT Edge certified devices. So I normally take people there and say, okay, here's your starting point. Here's
Don't
a catalog.
Choose anything not in this catalog.
And it doesn't have all of the devices that, all the edge devices out there, but it is the ones that are certified with Azure IoT for IoT Edge. So you can feel confident in knowing that those devices will work with Edge. Doesn't mean that if you have a great gateway out there that you can't use it. Just make sure that it has Docker support on it. That's really what I wanted to go through there.
I think it's great. I'm already, I've run into many customers too, and it's like, what are you trying to do? Sometimes I'm trying to move workloads from the cloud to the edge. Sometimes I'm just trying to do a protocol gateway, and those are vastly different choices about hardware and how things go together. So yeah, I definitely think it's worth digging into some more.
Exactly. Okay, perfect. So we're gonna move on to create and deploy IoT Edge modules. So we're gonna go over that overview walkthrough, just because I think it was kind of hard to wrap around. Let's just wrap everything together. Let's have a nice visual. Then we're gonna build that IoT solution and VS Code and some additional tips, and then we'll be on our way. So let's go ahead and get started.
Yeah. So I think that if we take a look at how does this solution kind of all go together? I think that's kind of what we're taking a look at. So we talked about before the Azure machine learning workspace and services. And so, the first thing that we did is we created that image, and I've called it classifier here, but it's an image with a classifier in it. And so the first thing that happens when we publish that image is it gets pushed into the Azure Container Registry that's associated with our Azure Machine Learning Workspace service. I feel like that one deserves a TLA. So I think that's the first thing. Then what happens is you go to your VS Code and you build your custom modules, the things that actually sort of help you route and help you write and make decisions for you, where your custom code is going to go for the edge. You build those things and you push those to the Azure Container Registry as well.
Yeah.
Now when you get ready to actually deploy to your Azure device, what happens is you just see that you push the deployment template to the IoT Hub, and then the IoT Hub lets the Edge runtime running on your Edge device know it's there. The Edge runtime pulls it down, and based on that configuration, the Edge runtime goes ahead and pulls those same modules from the container registry down to the local device, and that's it. So now you're running those modules on that remote device. So kind of keeping that in mind, and thinking of these things as they're all Docker containers. That's gonna help a lot when you start to think about, how do I diagnose what went wrong with my code here?
Yes.
You can go in there and use sort of standard Docker commands and look at those images and actually look at those containers and their running and their logs and see what's going on, and that really helps with figuring out why did things go so awry for me.
One question I get a lot is, why don't I just use one big module? Or why am I separating this out? And the way I kind of answer it is that think of these modules as you could deploy them in different solutions.
Right.
So if you have one for this ML model, you can take this ML model and maybe use it on another edge device that's doing a totally different solution. Or maybe you have different protocols you have to think about as well, like OPC UA, or maybe you're using XBs and you want to, have a module that's just for that.
Right.
So definitely think about that, and I find it easy to kind of think of them as mini services, like that.
That's
you're just putting
exactly
into
right. Microservices.
Yeah.
I think the one other thing I would add to that is sometimes you're doing it because there's a natural affinity for tools that go with the person who's developing it, right? So when you look at that classifier, that's built in Python and maybe TensorFlow and those kind of tools that the that your machine learning folks are comfortable
100%,
with. In our case, the router module is written in C#. Why? Because I've written a billion lines of C# in my life, and so that's really comfortable for me. And then the writer module got separated out because it turns out it's really easy to work with Avro in Python, and so I wrote that one in Python just because it was easier. So it lets you really mix and match your tool set to match with your with the problem that you're trying to solve, which is really cool.
Yeah, you see that all the time with people using different programming languages. So you're not tied You could use anywhere from Java, C Sharp, C, Python, and so I really like that flexibility.
For sure.
All right, let's go ahead and show your screen.
Okay. All right. So I think maybe the first thing we'll do before we even take a look at the Azure, the VS Code and how we built those modules. I just came back over here to the Ubuntu Edge device that we built, and I'm just going to go Docker PS. Except then I'm going to remember that I need to type sudo. And what I want you to notice here, and I know there's a better way to format this, but I can't remember it off the top of my head, so we'll go with this.
It works.
That you already see that we have these modules. They're running down here locally. You can already see what's going on. So if I want to say what's going on in the Edge agent, I can do something like Docker container. If I can spell, no, I can't. Edge agent. And once again, I'll remember that I need to use sudo.
Sudo.
And you can see I get the logs for what's been going on there, like what has happened. So I go make a deployment, and I want to know, did my deployment happen the right way? I come back here and I can take a look, and I can see what's going on that machine. So it's really handy to kind of get comfortable with those Docker commands and learn how to use sudo. And it really does a lot of good. Particularly when you start to look at the classifiers and like, oh, what's the turbofan router module doing right now, and how are things working? It really helps to figure that out.
And I've noticed in a lot of teams is that most folks who are working with hardware don't really have a background with working with Docker. And so there is some upskilling there just to kind of wrap your brain around Docker. Take some courses. I swear it helps a lot to kind of understand how containers work. And so I do recommend that.
Yeah, I absolutely agree. It's well worth the time to kind of get to it. And if you needed further proof of the fact that that's the case, I thought I'd kind of just take you through this solution just a little bit. The first place I wanted to start is with the routes. So the idea of our Edge runtime is that it's super loosely coupled. We can grab modules from wherever, and we can tie those modules together using sort of well-known inputs, and just establish routes and tie them together and change those without having to redeploy or rebuild or whatever. So again, going back to your point of why do multiple modules? Because then I can deploy them differently. I may want to see, maybe I want to insert a logging module just for a few hours between two of my existing modules. I can do that with the loosely coupled stuff.
Yeah. And it's nice to have those routes of just understanding where your data is going between module to module to module. You might have some data that's going to go into a blob storage module. So understanding and hooking up these modules are really important.
Really helps. So I'll start up here just kind of, so you see that in this case, we have three modules. We have a turbofan classifier module, we have a turbofan router module, and we have the Avro file writer module, just the same three that we were just talking about before. And you can see this deployment.template.json, you're going to find that at the root of your solution once you create an Edge solution. So now I'm going to come in and take a look at the routes here. And what you can see with the routes is that, one thing, to keep your sanity, you probably want to name the routes in a way that helps you understand what they're for. Because otherwise you're going to be looking at, route 1, route 2, route 3, and you're going to be like, why do I have these routes? What were they for? So here I've said, okay, I've got leaf messages to the router. So we know when a message arrives from a device, from a downstream device, it has no connection module ID because it's never been through a module yet. And so I can recognize that we have these new messages coming in, and then we route them into, as you see, the device input for the turbofan router. And then it just kind of carries on that way. We've put a drawing in the document that kind of helps you, like, okay, where's this thing going from here to there? and that kind of lets you take a look at these, so you don't have to look too hard. But I think Pamela's going to pull it up for us. But you can see that you're going from this output, AML output, which you define in your code, into a brokered endpoint on that module. So that's how they work. And then let's take a look at the overview real quick. So you can see here how our modules are kind of hooked together. So you see new messages coming in from a Leaf device, or a device really. Hit the device input queue. That goes into the router module. The router module then pushes data, transforms it a little bit, pushes data into the classifier output. The classifier output gets picked up by the AML input, which gets the classifier to do its job, which puts it into the AML output, which gets picked up by the RUL, not NUL, input, and then the router takes that and pushes it over to the Avro file writer, where it gets written to disk, and then eventually the Avro file writer will upload that data. So it's just good to know, like, that's how my routes are working. This is what they're doing. There's this concept of upstream, which is kind of pushing data forward, and we've done our best to make sure that the routes are copied into the or in the documents properly, so you don't have to get it wrong. But again, this is a time when you'll want to go in and take a look at what's going on in your modules. Also, you might notice here I've got some like dead messages. I don't know what to do with it, so I just push it to the upstream folder so that I can take a look at those later. We want to use this for logging and all kinds of things. So so that's the routes. There's another little gotcha here, and it's just I guess I can show this. So when you're going to go and build your Edge solution, what happens to me every time is I go and I try to build, and it says I can't connect to the Docker endpoint. I'm like, oh yeah, because I forgot to run Docker. So then I go back and wait for Docker desktop to run. The second mistake I always make, and this one is more frustrating because things run for quite a while before the error happens, is I forget to log in to my container registry. So I need to run Docker login, and log into the container registry, and you can find the password and username and all that in the portal, so that when Docker tries to push the new images there, it's able to do that. And so those are two kind of gotchas that I want to make sure you pay attention to. And then the other tricky bit in this particular solution, and I think it's worth taking a look at, is the Avro file writer itself uses some bindings. So it uses some bindings to allow it to write data to the local storage on the Edge device. Now, if you're using the storage container that we talked about earlier for Edge, then you wouldn't need to do that anymore.
Yeah, you can just put it on it. Yep.
But what you'll find is that has a different set of bindings, but that are very similar. And then the second thing it does is it uses a binding to get around the fact that there's a bug right now in Edge that I need to sort of work around by allowing my module to have access to the config file, read only. And so that's what you're looking at here, is just kind of these, in the Docker file itself, it goes along with these. And one of the things that's really fun about Edge is that you get to keep three different Docker files in sync with each other all the time. So that's lots of fun. I haven't done that in this case, but normally you want to make sure that this file, the debug file, and your ARM32 file, if you happen to be using that, are the same, or perhaps just delete them if you're not going to use them and realize that they're not going to be the But you can see that's what we've done here is we've made those two bindings. And then again, back in our deployment.json, you can see in the module itself where we said, hey, well, there's some create options for the module that cause it to do the bindings. So those are just two little gotchas that kind of come up here. Other than that, I think follow the walkthrough, create the modules, build and deploy, and oh yeah, there's one more little gotcha, and this is a good one. So you'll notice that we have a module version in here, this thing called module.json. So there's a module version in here. That module version is actually the number that's going to be published when you publish your image. So if you don't roll that number forward when you publish your new images to Docker, when you publish your new Edge device implementation, it'll say, oh, I'm supposed to have version 1. I've already have version 1. I won't even go check to see if those are different. I'm just gonna stay here. So you have to pay attention to that version number and roll it forward if you expect it to change.
Yeah. Yeah, definitely.
And
that's a gotcha. Yeah.
Yeah, for sure. I probably make that mistake, twice a week. And so I think then the last thing you might want to take a look at is just how do we actually build? So we'll build and push our IoT solution. And what you see is that just runs a Docker command. And that's gonna run for just a few minutes while it goes. And then once it's finished, what we'll do is we'll come to this config folder, which is at the root of your Edge solution. Right click on that guy, create deployment for a single device. And then you'll see the turbofan device that you've set up. This is our Edge device. I click on that, and then the deployment hopefully succeeds, and that'll cause, on the other side, if all goes well, how about a sudo?
Yeah, you just. I was going to stop you for a second.
So see, you notice that when I showed you that we were on 0.0.2 of our Avro file writer. So you've seen already, and comparatively, it's been up for 3 seconds compared to 16 hours for the rest of these guys. And I think if we look in here, we'll actually see that we got the update, config change, and we stopping the Avro file writer, or saving stuff. And so you can really kind of pop back and forth and see how things are working for you. So, that's all set up and ready to go. And I think we're down to we need to send some data through the Edge device.
Let's do it. We have everything set up. The routes are set up. We got our data. We're ready to go.
All right. So the most important piece of information that we're going to need to know in a minute is what is the fully qualified domain name of our Edge device. And luckily, that happens to be in the portal. So if I come over here and I find IoT Edge and then dash, and there'll be some crazy numbers there. It's just randomly generated, and click into that. I'll have the DNS name here. Conveniently, that DNS name is in lowercase because remember, if it's not in lowercase, it's not going to work. So I can copy that to the clipboard so that I have it handy when I get back to our turbofan device. So the only difference really here, that when we run this,
and while you're doing that, you can actually see routes. You can see your IoT Edge devices, all your devices connected to IoT Hub through the portal.
That's right.
So I do think it's important. Maybe we could just let's just go there after everything's deployed.
That's a good idea. We can also take a look at the data there too. Again, just to kind of
just
do.
To
but
show
you're right.
Visually.
That's a great point. So you'll notice that I think all of these will turn back to being blue again because we haven't sent any data. The big difference we're going to do here, if you kind of look at our new command versus our old command, is we're going to pass this gateway host name. Now, if you go look in the documentation for the script, what you're going to find is that it's down here. When we find a gateway fully qualified domain name attached to the command, we add that as to the connection string with gateway host name equals and then that name. And so that's what causes us to talk to the edge device rather than talking directly to the hub itself. A little gotcha here: if you give the wrong fully qualified domain name, it will often just work and it'll talk to the hub. It'll just sort of ignore you. Kind of, I assume it's like your cat, it just assumes that you don't know what you're doing, and it goes on without you.
So you need to check that.
So you have to check that, and I usually just run it from the command line inside of the Visual Studio Code. So
terminal.
The terminal. Oh, actually, there's two changes. The second change is the certificate. So we said we were going to talk about why we needed certificates, but
then we skipped over
then
it.
we didn't
until we needed it.
So when you have the edge device sitting on the edge of your network, and you have a device that wants to connect to it, how does that device know that the edge device it's connecting to is who he says he is?
Exactly.
And so we use TLS, like everybody else in the whole wide world, to do that. And the way that works is that the edge device itself has an intermediate certificate installed on it. That was one of the certificates that we installed. When the edge machine starts up, it takes the host name and creates a certificate to be used for TLS. There's a whole article about this in our documentation. And then that creates a certificate that you're going to use for TLS. Because we're using fake certificates here, as in the root CA is not real, it's just one that we made up. We need to tell our local machine to trust that fake made up root CA. So if you're using real certificates on your gateway device, certificates with an actual certificate authority, you wouldn't need to do this step. They would just connect, because you would go to the actual certificate authority and say, is this a meaningful certificate? Should I trust the certificate?
Yeah.
And then it would all just work. But because we're not, we need this certificate here in order for things to run.
And if you're using the device provisioning service too, that's a different story, because device provisioning service, you can use your IoT Edge devices with that. So if you are using that, you could do group enrollments, individual enrollments, but I won't deep dive into DPS right now, but I just wanted to make a mention. There is a service that connects devices securely, and they do that by X509 and through
symmetric key, right?
Yeah, and then also TPM.
Oh, TPM, right?
Yep. So those are the two main ways.
Okay. Yeah. So anyway, so that's what we're gonna do. We'll hit run. Hopefully the demo gods are with us again. Not. Oh, it is. That's fine. So the certificate is already installed, is what I was saying, and then it's asking me for my IoT Hub connection string. And we'll hopefully see is one of the devices selected at random will start sending data. So it sent its 250 messages through, and we can go over it again and take a look at the Docker logs and watch them run through and so forth. We'll leave that for a later date. I think we're quickly running out of time, so we'll kind of leave that for later. But that's all gone through. And then, so I think the last thing we just wanted to take a real quick look at was the hub itself.
Yeah.
So here, and you can see a few things are interesting. One is you'll see the device to cloud messages. You can see how those are running through. There's a little bit of lag, of course, and you can if you drill in, you can get a smaller time range to take a look at. That's a a really good way to kind of see what's been happening. And then the other place to go and look, in our case, we're talking about edge devices. You can also look at IoT devices through the same mechanism, but we'll focus on edge for the moment.
Yeah, this is nice to see, and then you can also see the actual routes.
That's right.
As well.
So so we can see, like, here's our edge device that we have. So I'm drilling into that, and you can see like where everything is. I think if I go to set modules, you'll see that we have, here's the modules that we have running, and then when I click next, here's the routes. And so you see it's the exact same routes that we saw before, actually, in the same JSON format and everything. So yeah, it's really easy to see what's going on here and make sure things are working, and kind of look at where your data is flowing through. So
and you can change your routes within the portal too.
Yeah, that's right.
And
You totally can. Like it's, you know, like we were talking about before, if I wanted to add a logging module in here for a little bit, it would be very easy to say, okay, you know, take the output of the turbofan classifier and put it into a logging module, and put the output of that back into the router, and neither the router nor the classifier would know it was there. It would just be here, and I can even deploy new modules from here. I think there's, you know, we're building up a marketplace of modules, and
yes,
so.
I was actually gonna pull that up real quick.
Great, that's I totally meant to do that.
That was a transition that I've been waiting for this whole time.
that was me with the toss, right?
There you go. He even had the tab up too. So we just showed you how to deploy and build that IoT solution. So you actually got to see the routes, you got to see the information in the portal, see the visualization of the data as well. And I just want to do a quick plug that, you know, there's already a lot of modules that are pre-built. And then we also have a lot of it, you know, example code and everything else. So if you were looking at that module that was created, that ML module, and that was overwhelmed by it, just know that that is not the only way. We're just really showcasing an end-to-end experience of building a model by scratch and deploying a whole new edge solution. And so we do have a marketplace where if you have a model that you want to put in the marketplace, you can. We do have directions for that, but if you want, let's say, get COG services, you can get that here. It will be able to deploy in your IoT Edge device. This one, we have examples, we have language detection. I won't go through all of these, but it has a lot of support here, especially if you're using Redis. So I just wanted to give that call out. And also, you can actually get these through VS Code.
Right.
We just released about, I think it's like 2 weeks now, where you can
really
pop up in VS Code on the marketplace. So you can easily just go, hey, I really want to look at this example, or hey, I really want this module to deploy in my own solution. You can do that in VS Code. Not in Visual Studio yet.
We're getting there.
But we're trying to have that equal love going on between the two. So let me go ahead. Was there anything that you want to close off with?
I don't think so. I know this was a whirlwind tour.
It was.
Even a very long whirlwind tour was a very whirlwind, and there's a lot of ground to cover here. I really hope the documentation is you know helpful. That's on the GitHub. If it's not, hit us in chat. Hit us on
issue.
Yeah, create an issue. We're paying attention. So
and you might have mentioned throughout when we were talking, we were like, this is something new that popped up. We're constantly adding new features to simplify this, because it's one thing to deploy a COG services and you get ready and then, you know, in 15 minutes and you're good to go, versus actually building something from scratch. And so we really want to make sure that we're changing this experience and having a better developer experience with it. So definitely reach out to, do you have a Twitter handle? I'm doing a plug.
Of course I do not.
I should have asked you before.
Look how old I am. There's no way I have a Twitter handle.
Yeah, that's not
My MySpace page.
MySpace. Can I be part of your top 10 MySpace friend? Well, there's a couple different ways you can contact us, but I'm throwing this resource page up here, and I'll link it into our actual YouTube video and also in tech communities. But here is the sample that we went through. Actually, is on Azure samples, and it focuses on predictive maintenance. But you can actually go through this, do some pull requests. That would be nice.
That'd be fantastic.
That'd be fantastic. We're also looking into putting this in our docs, and I also have links to docs on all of our different resources that we have to make this easier for you. I think we picked the most challenging example to go with, because we wanted to show what are the different things you had to think about if you were fully going through this scenario. We also have the IoT tech communities. If you're not part of it, I recommend joining. It's free.
Yeah.
Anyone can join. We don't collect your information, but I normally post these slides, give updates. Olivier, who is the other host of IoT Show, he does a weekly recap of the week of what's been going on in the IoT community. So go in there. We would love to have more discussion in that area. And that's why I'll be posting more links.
Awesome.
And you can find me on Twitter. Thank you for joining. We look forward to hearing your feedback. And we're going to be having a series of Intelligent Edge deep dives. So if you wanted to get started with NVIDIA Jetson, I will be having that one coming up. So thanks for tuning in.
Yeah, thanks. Thanks for having me.
Yeah, thanks for joining, Mark. Okay, bye everyone.